Okay, now we're going to look at some more advanced methods for determining some limits that require a little more intense algebra. So the two we're going to look at now are combining fractions or rational expressions and absolute value. So let's look at combining fractions first. There are a couple of different ways that you could do this. My personal favorite is to, with this first limit, first of all, when you try to plug in 0, hopefully we run into lots of issues here. You'll have 1/5 minus 1/5, but it's times 3 over 0. So we have universe explosion right there. And so for this problem, I can't factor because we don't have a quadratic to factor or anything like that. I'm going to try and combine these rational expressions first. I'm going to try to subtract them, but in order to subtract them, I need common denominators. So I'm going to go ahead and multiply this first expression. I'm going to do nothing with this for a little bit. It's just going to hang out outside. I'm multiply this first expression on the top and the bottom by 5 minus x. And then this expression I'll need to give a 5 plus x on the top and the bottom. All right, and so I'll still have my 3 over x out front, and then I will end up with 5 minus x over 5 minus x times 5 plus x. Okay, and then in the second expression now, I will have 5 plus x on top over 5 minus x, 5 plus x. And since these now have the same denominator, I can combine them into 1. So lovely. I'll go ahead and simplify the top a little bit. My numerator will end up distributing that negative. Careful. And so then we'll have 3 over x times, when we have that, our 5's will end up canceling out, and then I'll have negative 2x's on top. Oops, there we go. All right, and now the fun part is that I'm getting rid of my problem causer, this x in the denominator, because it cancels with that x up top. And so then secretly what I'm finding the limit of is I'm just going to be finding the limit of, as x approaches 0, of on top I'll have negative 6. And then on the bottom I will have 5 minus x, and then 5 plus x. And so then this will give me what this actually equals. When I plug in 0 for both these pieces, I get negative 6 on top, and then I'll get 5 times 5 on the bottom. So I will end up with negative 6 over 25 is my final answer. Lovely. All right, here's another example of how you could combine fractions. So I have two rational expressions, or a fraction and a rational expression in my numerator. And so first and foremost, if I plug in negative 4, I'd end up with 1/4 minus 1/4, so you get 0 on top, and then on the bottom you get 4 plus negative 4, which is also 0. So I'm going to go ahead and get common denominators between these two top rational expressions, so that way I'm able to add them together. So let's do that. So we'll give this guy, we'll get a 4 over 4, and then this guy will get an x over x. Okay, so then I'll end up with x over 4x plus 4 over 4x all over 4 plus x. Since they have the same denominator now, I can go ahead and combine them. So I get x plus 4 over 4x over 4 plus x. And as we know, when you have fractions inside of fractions, we can go ahead and flip and multiply. So this becomes a 1 over 4 plus x, and it's multiplying now. And now since it's multiplying, I can go ahead and cancel out these two. So really, I'm just left with finding the limit as x approaches negative 4 of 1 over 4x. And so then, well, that'll be my answer up here. But it's also my answer down here. So if I plug in negative 4, I get negative 1/16. Voila. So that's how you might have to deal with some rational expressions and getting common denominators. There is just algebra solving is a little bit trickier for those couple of problems. And then the last thing we have to look at are absolute value equations, and I'll show you how to deal with them. So technically, absolute value functions are made up of piecewise functions. And so the first thing we do is we find what I call the breaking point for my absolute value function. So where it switches from being positive, like what would cause it to be 0, and that would be at an x value of -1. And so then I'm going to break up my absolute value into a piecewise function now. So now my absolute value of x plus 1 over x plus 1 would be this. So if you have values that are greater than -1, so let's say like 12, do your absolute value symbols actually matter? 12 plus 1 is 13. Do your absolute value symbols actually do anything to 13? No. So for all x values greater than -1, you technically don't even need absolute value symbols. Okay? And then for all x values less than -1, you absolutely need absolute value symbols. Or what actually happens is it changes signs, right? So if I plug in like -10, -10 plus 1 is 9, or -9, and then my absolute values switch the signs. So basically they take whatever's on top and they switch the signs around. So it's like they're sticking just a negative out front there. Okay? And then if I go to simplify this, I end up with x plus 1 over x plus 1 reduces to 1. And then negative x plus 1 over x plus 1 reduces to -1. And so then basically this is what my function breaks down into. And so if I was going to take the limit of a piecewise function, remember we have to test from the left and from the right separately. So if I was going to do the limit of this function as x approaches, oh gosh, sorry, I got craziness happening right now. So as we have the limit as x approaches -1 from the left-hand side, what this would end up going to is, if we look at values just less than -1, we'd get -1 as our answer. And then if we looked at the limit of this function as x approaches -1 from the right-hand side, we'd end up going to +1 based off of this piecewise that we created. So this limit actually does not exist, because your left-hand limit and your right-hand limit are different. So absolute values are tricky because you have to break them down into their piecewise functions and then see what's true about that. All right, we're going to do one more. All right, in this problem, I have two pieces that are going to be piecewise functions, or two absolute value pieces that are going to be piecewise functions. So I'm just going to break up those pieces individually and, for example, see where their breaking points are. So like I said, our first step was seeing where their breaking points are, and then our second step was to actually make our piecewise function. So let's do that here. So for both of these, let's see, 3x plus 7, let's see what its breaking point is. And then the same thing with x plus 17. So we'll end up with -7/3 and then -17 as our breaking points. And so then I'm going to write piecewise functions for them. So I will have 3x minus 7 as its own piece. So for x values greater than -7/3, and then x values less than -7/3. If it's greater than 7/3, so if it's like 20, I won't need absolute value symbols, so it can just be 3x plus 7. But if it's less than -7/3, I would definitely need the negative out front, because it would be what changes signs. Sorry, I'm writing a little small there. It's a little messy. And then for my x plus 17, When I break that up, I'll end up for values greater than negative 17 and values less than negative 17. For values greater than negative 17, I won't need absolute value symbols, so I can just leave that alone. And then this one would change the sign. All right, so now what I have to do is I have to look at what my x is approaching. Previously, we were approaching -1, and -1 was the breaking point, so I had to test my left and right hand limits. However, because I'm approaching 5 in this problem, I don't actually have to consider the exact, like both pieces of both piecewise function. So when I do, for example, when I do x approaching 5 in this top one, I'm going to be looking at just these pieces for x greater than -7/3 because 5 is greater than -7/3. Same thing with this bottom one here. I'll only consider this top piece as well. So technically what this has led me to see is that I'm only going to be considering the fact that I can replace my absolute value symbols with just their actual functions because I'm approaching 5, which isn't, I don't have to consider the fact that I would need negatives at all. So let's do it. Well, actually, let's do it down here. So I'm going to replace it, x approaching 5, with just the regular 3x plus 7 now, and then an x plus 17. Careful, I still put parentheses around here because I'm going to have to distribute this negative. So then I'll end up with, let's see if I distribute that negative, I'll end up with 3x, and then minus x would be 2x, and then 7 minus 17 would be -10. Okay, but I still have my problem. If I try to plug in 5, I'd get 0 over 0, but I see one more step I can do, and that would be to factor, pull out that 2 up top. And so then I end up with just 2 as my answer. Cool. All right, these ones are quite tricky, so if you are still struggling with them, let me know, and maybe I can do some more examples for you. But other than that, go ahead and get that practice done, and like I said, let me know if you have any questions.